Hi everyone, I am Dr. K.S.Rangasamy, Professor, Department of Mathematics, K.S.Rangasamy College of Technology, Tiruchengood, Tamil Nadu, India. Today we will see the important topic in multiple integral. The multiple integral, we see the double integration in Cartesian coordinate problems. We see the first problem. They evaluate the given interval 0 to 1 and 1 to 2 x into x plus y dy dx. This is the given Cartesian coordinates double integration problem. Now, how to solve this problem? Here we know that the integration with respect to dy and dx. So let the given problem I define I equal to integral 0 to 1 integral 1 to 2 x into x plus y dy dx. Let we assume that the given problem only the I. So now the Cartesian coordinate we have the variable x, that's we multiply the x inside the bracket, we have the value the integral 0 to 1 integral 1 to 2 x square plus xy dy dx. So now again this integration we have the two integration value with respect to y and x. The first here the integration with respect to y, after that the values again they integrate the dx. That's why we take that the first integration value, our limit value 1 to 2 x square dy plus integral 1 to 2 xy dy. After that this value integration with respect to again dx. So now we go to the integration of the first interval x square into y, the integration of the first one, the limit value 1 to 2. See again the second part x into y, the integration value x y square by 2, the limit value 1 to 2. The overall again we need the integration with respect to dx. So now we substitute the first integration value x square into y 1 to 2 plus x by 2 into y square, the limit value 1 to 2 into dx. So now we substitute the limit value x square into the upper limit value 2 and lower limit value 1, and second of x by 2 square and lower limit value 1, therefore we have the 1 square into dx. So now they simplify this value, the integral 0 to 1 x square into 1 plus x by 2 into 4 minus 1 into dx. So now we know that integration 0 to 1 and the x square into 1 plus x by 2 into 3 into dx. So now again we simplify this data, we got it the x square plus 3x by 2 into dx. So now again we have the two term of integration here. The first one integral 0 to 1 x square into dx plus 3x by 2 into dx. So now integrate this value x square integration of value x cube by 3, the limit value 0 to 1, and now we remove the constant 3 by 2 into x square by 2. So now we substitute the limit value here 0 to 1 and plus 3 by 4 into x square, the limit integration value is the limit 0 to 1 again. So we substitute the limit first of 1 by 3 into 1 power 3 minus 0 power 3 is a 0 plus 3 by 4 into 1 power square minus 0. So we simplify this data 1 by 3 plus 3 by 4. So we take the LCM for 3 and 4 is a 12, just the cross multiply 4 times plus 3 into 3, we have the value 4 plus 9 divided by 12. The final answer of this problem 13 by 12. So now the another one, the multiple integral, the very important area, double integration in polar coordinates. This problem, how to solve the double integral problem in polar coordinates value. The first we see the given problem, they evaluate integral 0 to pi and 0 to a or dr into d theta. We identify this term of values, the integration with respect to r and theta will become the any problem. The integration is called the polar coordinates. This is a very important clue. So now let I define the given problem I equal to integral 0 to pi 0 to a r into dr into d theta. Now again we see that the first integration with respect to r, our limit value 0 to a, integration with respect to r means r into dr, the integral 0 to a. The another one integration with respect to theta, the limit value 0 to pi only. The first integration with respect to r, the r integration with respect to r means we have the value r square by 2, the limit value 0 to a. The next one we know that again the integration with respect to 0 to pi into d theta. So now integrate for the first value with the replace our limit value, the integral 0 to pi, our limit value, the upper limit value is a, therefore we have the a square by 2 minus the lower limit value here only 0, therefore the 0 into d theta. So now we simplify this data, the given data, the first of only we have the values, the integral 0 to pi a square by 2 into d theta. So now we know that again this a square by 2 is the one of the variable and constant, therefore we remove and entire the a square by 2, the remaining value is only 0 to pi into d theta. So now integrate d theta in of our integration, a square by 2 into only theta, the limit value 0 to pi. So now we substitute our upper limit lower limit value of the integration values. So we got it, the a square by 2, the upper limit value pi minus 0. We simplify this data, a square by 2 into pi, the final answer this problem pi a square by 2. I give here the 5 practice problem for our double integration. The first one evaluate 0 to pi 5 0 to 2 x square plus y square dx into dy, and second one evaluate 0 to 3 0 to 2 x into dx dy, and third and fourth problem here we solve the polar coordinates model. The problem evaluate 0 to pi by 2 and 0 to sin theta r dr d theta. The another one evaluate 0 to pi and 0 to sin theta r dr into d theta. This 4 problem you solve and easily understand the double integration in multiple integral area. Thank you for watching.